This is Ms. Steele's Precalculus Section 9.6 notes. We're going to be discussing the inverses of matrices and matrix equations. We're going to start with the definition of an identity matrix. An identity matrix is an n by n matrix, where the n by n is just the dimensions of the matrix. So it's an n by n matrix where each main diagonal entry is 1, and all other entries are 0. So the identity matrix for a 3 by 3 matrix has a 1 in the diagonal and zeros in all of the other spots. So this is the identity matrix for a 3 by 3 matrix. The identity matrices are like the number 1, since A times 1 equals A. So we know that any matrix A times the identity matrix I is equal to A, as well as the identity matrix times any matrix A is equal to A. And that just follows because multiplication is not always commutative with matrices, but multiplication is always commutative when just talking about pure multiplication. But with this being said, it's important to understand that when we multiply two matrices, so let's say we have matrix A and matrix B, if we take matrix A times B, that equals A times B. If we take matrix B times matrix A, we write that as BA. It's important to understand that these two are not equal. It is a special case with the identity matrix where we have A times I equals A and I times A equals A. Another definition we're going to talk about is the inverse matrix. So if there exists an n by n matrix, where again n by n is just the dimensions of the matrix. So an n by n matrix, A inverse, with the property that A times A inverse equals the identity, and A inverse times A also equals the identity, then A inverse is the inverse of A. So the way that we prove two matrices are inverses of each other is if we do matrix multiplication both ways, and if we get the identity matrix as a result of that. So the inverse of a 2 by 2 matrix, if we have A equals the matrix A, B, C, D, then A inverse is 1 over AD minus BC, where this right here is the determinant. And that's multiplied by the matrix D, negative B, negative C, A. Notice that the A and the D just switched spots, and the B and C became the opposite sign. So if they're positive, they become negative. If they're negative, they become positive. So it's important to note that just the AD minus BC is called the determinant of the matrix. Also, if the determinant AD minus BC equals 0, then A has no inverse. So there's no inverse of A. So let's take a look at an example. For example, when it says find the inverse of A, which we write A inverse without a calculator. So if A equals 6, 7, negative 2, 3, then we know that A inverse equals 1 over the determinant, which the determinant is 6 times 3 minus negative 2 times 7 times the matrix, where the A and D spots switch spots. So we have a 3 and a 6 in the upper left hand and the lower right hand corner. And the 7 and the negative 2 have a sign change. So the negative 2 becomes positive and the 7 becomes negative 7. So calculating this out, we know that the determinant of A, we have 6 times 3, which is 18, minus negative 2 times 7 is negative 14. So we can chop. 18 plus 14 is equal to 32. So we have 1 over 32 times the matrix 3 and negative 7, 2, 6. So now we're just doing scalar multiplication. When doing this, we just multiply that 1 over 32 to each term in the matrix. So 1 over 32 times 3, we can just leave as 3 over 32. 1 over 32 times negative 7, we can leave as negative 7 over 32. 1 over 32 times 2 can be reduced to 1 over 16. And then 1 over 32 times 6 can be reduced to 3 over 16. So this is our A inverse. To find the inverse of a 3x3 matrix, I will not be teaching you guys how to do that by hand. However, there is a way, but you will learn in college if you continue taking math courses in college. On a test, you will only be able to, or you will only be tested on solving finding the inverse of a matrix of a 2x2 matrix. So I'm gonna note that on the test. You will only have to find the inverse of a 2x2. So if we want to find the inverse of a 3x3 matrix, we are going to get out our graphing calculator. So again, just like we taught the other day, if you go to second, the inverse, we'll go to the matrix, and we'll go to edit, and then scroll down to matrix C. Since it's a 3x3, we'll change it 3x3, and we can go ahead and type in the corresponding values. So we have a 3, 2, -1, 4, 0, +1, 5, 6, and -2. So once you have your matrix, we can go to second and quit. And now to find the inverse, we will go to second matrix, go down to the 3 where it says matrix C, click enter, and then click the inverse function. Once we have this, we can click enter, and it shoots out our matrix. If we want these to be in fractions, we can go to math and go to fraction, which is just the first one, and it will shoot us out a matrix in fractions. So then the determinant, the inverse matrix of matrix C is 3/8, 1/8, -1/8, -13 over 16, 1/16, 7/16, -3/2, 1/2, and 1/2. So the relationship between matrix A, its inverse, A inverse in the identity matrix, the 2x2 matrix, is that A times A inverse is equal to the identity matrix, or slash and the matrix A inverse times the matrix A also equals the identity matrix. Example 3 asks us to calculate AB and BA to verify that B is the inverse of A. Notice on the front page that I said that AB and BA are not always equal to each other because matrix multiplication is not commutative. So matrix multiplication is not always commutative. So with that being said, let's multiply our two matrices together, AB and then BA. This is definitely possible to do by hand, but just to save time, I'm going to do it by the use of a calculator. So getting out your calculator, I actually went through and already typed in my matrices A and B. So if you'd like to pause the video and take time to do that right now so you can do this with me, that would be great. Otherwise, to multiply the two matrices, notice I'm on the home screen, so I go to second matrix, click A, enter, and then times second matrix, go down to B, enter, and then just click enter, and we get the identity matrix, 1, 0, 0, 1. If we wanted to do B times A, the same type of thing, just B times matrix A, click enter, and we also get the identity matrix. So when we multiply together AB, we got the identity matrix, 1, 0, 0, 1, and we multiplied BA, we got 1, 0, 0, 1. Notice we got the identity matrix both ways. So since AB and BA are equal to I, the identity matrix, then matrices A and B are inverses of each other. So this is the one way you can prove two inverses are, or two matrices are inverses of each other. Another thing we're going to talk about is using an inverse matrix to solve a linear system. Your first step is to convert the linear system to a matrix equation. So if we are given a linear system, 3x plus 4y equals 10 and 7x plus 9y equals 20, typically we would use either graphing, substitution, or elimination. However, we can also use matrices and create a matrix equation. So in the first matrix you see on the left, this is called the coefficient matrix of A. Where A is just your, this is what the matrix is called, matrix A. The middle matrix is going to be the variable matrix of X. And X is just what we call this, the middle matrix. And the last matrix on the right-hand side is called the constant matrix B. And again, we call it B just because that's what our resulting matrix is. So the coefficient matrices of A, we're going to be listing the coefficients of X and Y. So we see a 3, a 4, a 7, and a 9. In the variable matrix, we'll be listing an X and a Y because those are the two variables we're concerned about. And then in our constant matrix B, we'll be listing the 10 and 20. I will be continuing the rest of the problem in the second part of this video.